We're subtracting rational functions, and in this example, we have a common denominator. So with that common denominator, what I could do is I can go ahead and write this single denominator of x squared minus 64 here, and in my numerator, I can go ahead and perform the subtraction. But it's important that I put the parentheses around all of 3x plus 8 because I'm subtracting all of that. This is going to give me 4x minus 3x minus 8. Now that denominator is just a difference of squares. X plus 8, x minus 8. And factoring that into the difference of squares will allow me to see if I can cancel any factors. And when I clean up that numerator, which is just x minus 8, because 4x minus 3x is x, I do see that I will be able to cancel a factor of x minus 8. So this will cancel, and we will be left with just 1 over x plus 8. Now, as for the restrictions on the domain, we cannot have plus or minus 8 for a value of x. So x cannot equal plus or minus 8, and that's coming from the fact that when we were here or even here, we recognize that a value of x plus or minus 8 would make that denominator 0, therefore undefined. Now we have two other functions that were given here, and we're going to perform the subtraction of these two functions. So we want to subtract from f g, and we know that f minus g is equal to f of x minus g of x. So to begin, we're going to need a common denominator. So I'm going to go ahead and write 3x over 3x minus 1 here, and I'm going to subtract off 4 minus 14x. But I want to go ahead and see if I can rewrite this 3x squared minus 4x plus 1 differently, and so I'm going to factor it. So I'm going to use this AC method, and 3 times 1 is 3. I have a negative 4. I need two numbers who multiply to give me 3 and add to give me negative 4, about negative 3 and negative 1. This will allow me to factor by group. And when I do, I'll be able to, for group 1, pull out a 3. That is what's common there. Actually, 3x. Factor out a 3x. And then we're going to have to multiply by an x minus 1. Bring down my sign as minus. What's common with x plus 1 is actually just 1. So 1 times an x will give me back the minus x, and minus 1 times minus 1 will give me back 1. So I've got a 3x minus 1 and an x minus 1. So I have successfully factored this here into 3x minus 1 and x minus 1. So now I'm recognizing that I don't quite have a common denominator, but I'm close. See, each of my denominators have a factor of 3x minus 1. So it's only this f here, my function f. This is the only one that needs to have the missing factor of x minus 1. So what I need to do is multiply by the x minus 1. So it's x minus 1 on top and bottom that I need to multiply to my 3x over 3x minus 1 in order for me to have that common denominator. So now when I multiply through, I have 3x times x minus 1. So this is going to give me a 3x squared minus 3x. And notice now, when I multiply, or pardon me, when I subtract through here, I'm subtracting all of 4 minus 14x. So that's going to be minus 4 plus 14x. And because these have a shared denominator, a common, I can go ahead and just write it as the single denominator, 3x minus 1, x minus 1. Now let's clean up our numerator. 3x squared minus 3x plus 14x is going to give me plus 11x. And then we have minus 4. And this is all over 3x minus 1, x minus 1. Now, we have seen me factor plenty of quadratics like this. For instance, I just factored a quadratic here where I had to use AC method, factor by group. So I'm going to allow you to, on your own, factor this here in purple. And when you do, you'll find that this actually factors into a 3x minus 1, x plus 4. So once this is factored and you are here, you'll be able to do some cleaning up, meaning some canceling of factors. And what we'll cancel here will just be this. So you'll be left with an x plus 4 over x minus 1. And this is your solution. Now it's important that we also mention what the restriction is on the domain. The restriction is given as, well, we would take 3x minus 1, set it equal to 0, and solve for x, and x minus 1, set equal to 0, solve for x. In doing so, you'll find that x here will be equal to 1/3, and here x will be equal to 1. So these are the values of x that would make that denominator 0. So we cannot have 1/3 nor 1 in for x, because that would make the denominator 0, hence undefined.